Well, good morning, good afternoon, or good evening, depending on where you are in the world. I'm Charlene O'Hanlon. I'm the moderator for today's webinar, sponsored by Instana. Thank you for joining us today. Today's webinar is Managing Quality of Service for Containerized Microservice Applications. It's a really fascinating topic, and I'm sure you'll get a whole lot out of it. Before we get going, though, I do have a couple housekeeping items that we do need to go over. First of all, if you don't catch all of today's webinar, don't fret, because this webinar is being recorded and will be available probably about 24 hours after the event. The slides also will be available at that time. So if you have a desire to have the slides then, just know that you'll be able to get those as well. And we are going to be taking questions during this webinar. So I understand there's a demo as part of this webinar. So we will be taking the questions throughout the event. We're not going to be waiting until the end as we sometimes do. So if you have a question for either one of our panelists today, please feel free to submit your questions at any time. And as I said, we will be taking questions throughout the event. So don't wait, don't hesitate, get those questions in. We also will have 3 polling questions during today's event. So pay attention, because you will be we'll be asking you to give us your answer for the 3 polling questions. Okay, so as I said before, today's webinar topic is Managing Quality of Service for Containerized Microservice Applications, and it is sponsored by Instana. And today's panelists are, we're going to change the slide now. Here we go. Okay, today's speakers are Pete Abrams, founder and COO of Instana, and Michael Crum, product manager. Welcome to you both, gentlemen. Thanks for coming today.
Thank you very much. This is Pete Abrams. I'm one of the founders at Instana, and let me introduce immediately Mr. Michael Crum, who's our product manager actually in Germany. Michael, why don't you introduce yourself?
Yeah, thank you very much, Pete, and warm welcome from my end. As Pete already said, I'm leading product with Instana, and as you can see on the screen, my history is in App Dynamics, and before that in BMC, where I focused on monitoring, especially at App Dynamics, also in APM solutions. And before that, I was in a company, in fact, in the healthcare sector, building and leading a couple of departments, including head of IT. And before that, I was in the deep trenches of offering consulting and services in the IT.
Yes, thank you, Michael. And let me introduce myself a bit. I spent years at Sun Microsystems in the early days, selling and marketing their Unix workstations and servers. Then I moved over to a company called Net Continuum, which was a security company. And I spent actually 6 years at App Dynamics. I left there about 2 years ago. I was VP of Channel Sales and also VP of Innovation with App Dynamics. We founded Instana about 18 months ago, actually, but R&D before that was happening for about another year and a half. So I believe that we want to actually start with a polling question. So why don't we put that up on the screen, and then I'll keep going through the slides. I think.
Great. So here's the poll, the first of the 3, as I mentioned before. And by the way, thank you both, gentlemen, for introducing yourselves. Here's the first polling question. What is your DevOps team currently using to monitor the application stack? As you can see, there are 4 different replies: open source only, APM only, APM plus open source, or APM plus infrastructure monitoring plus open source. So I'll give the attendees, you guys, about another 15 seconds or so to submit your answer, and then we'll take a quick look at the results. Also, we are going to be tweeting out the results of all of the polls during today's webinar, so feel free to continue the conversation on Twitter if you'd like. Okay, so the poll is now closed. Here are the responses. Looks like we've got a dead even open source and APM plus infrastructure monitoring plus open source as the clear winners, with APM as a very distant third, or second, as it were. So Pete, what do you think of these poll results?
Exactly what I suspected, honestly.
Well, that's good, I guess.
You know, I think it shows a couple things. One is it's a myriad of tools, right? It's almost every customer we run into, and you know, we talk to 3 or 4 companies a week, at least me personally, and the company way more than that, is you know, struggling to really understand their situation at hand, their IT architecture, their IT systems, the business flow running across that, and then specifically, you know, the health of the applications, the health of their business services, and it takes a lot of different tooling and expertise to do that in today's world. And you know, that's really honestly why we started this company, because we saw an opportunity to consolidate the whole thing into a more cohesive approach. And are we switched back to my screen now?
Yeah,
Yes.
I see your screen. Yep.
There we go. Okay. And actually, I'm going to start with a statement from Gartner, which I know is a little bit boring, but Gartner is probably, as we all would probably say, the preeminent analyst of what's happening in the world of IT, and they very much have noticed a couple things. One is a shift in the way organizations are architecting and building and deploying their business applications, number one. And as that shift has started to occur, the shift to microservice, shall we say, the companies or the IT organizations are recognizing that their tooling is not exactly aligned to that new architecture. And that, they started writing about this quite extensively. There's about 4 reports out. I've taken a quote out from a report called, on Gartner report titled, How Microservices Have a Macro Effect on APM. This was published in June by the key guys, the key research guys who very much focus on the world of monitoring and infrastructure and operations, et cetera, and specifically also APM. A quote I'm pulling out of there: microservice architectures bring new complexity in terms of scale and dynamism to assessing the status of the application environment. Right? Let's all go back and just take a big step back. When companies go, you make the investment to build a specific business process, build their applications to really model their specific, business process. That's a major investment. And that investment needs to be backed up with high quality of service or operational capability. And that is why, the current APM space is, about a $3.5 to $4 billion net spend worldwide. That's why corporations are making that expenditure. But there's a really interesting moment in history right now, and that is people are realizing if I'm going to shift to microservice, and there's a lot of good reasons for that, then I'm going to have to rethink my tooling strategy. And that is really, the founding reason for Instana's existence. Now, interestingly, when Gartner found out what we're doing and, what our approach is, which of course we'll be talking about in detail, they gave us this Cool Vendor Award, feeling like, wow, this is a company that is seeing this shift and has specifically built their solution to help with that, with this new situation at hand. So let's start with a quick definition of what a microservice application is, because it's kind of so on steroids, but let's get detailed about it. First of all, one trend we're really seeing is the polyglot word. Microservices are almost always written in a different language. So we typically see a minimum of 4 different languages being used by an IT organization these days. The most popular for new microservices is Python, Ruby, Go, PHP are really making a comeback. The traditional world of Java, certainly most code is still in Java, and most existing code, and lots of new microservices are being written in that. But there's an amazing resurgence of these shall we call them less capable languages, to the Java bigots. They're maintained independently. Glad I got a laugh out of you, Michael. maintained independently, meaning there's a different operating team that manages each service. They're deployed automatically, often, not always, but almost always. Often terminated after use, invoked on demand, scaled dynamically. Those are dynamic words, right? That is a very different world than the world that we're used to. So I make a closing statement here by saying no longer are applications rigid, hardwired blocks of functionality, but rather, the business processes that they deliver are made from the interactions of the multitude of the microservices and also the traditional services. Right, so that's sort of the new world, highly dynamic, much more message focused, right? The processing happens by lots of messages between these small services. Another interesting thing, new fact. Modern systems are built with resilience. Hey, almost every one of those services is a little cluster, right? So failure of any component is assumed, right? We assume that any part will fail, and that puts a new spin on monitoring as well. The new quality of service challenge, in our opinion, is the dynamism and the interactions between those components, not so much the piece parts. In fact, Gartner writes about this a lot also, saying that another way to define a microservice application is this. Any microservice can think that it's perfectly healthy, but the application is actually broken because they're not interacting properly. So that's a very different world for monitoring to deal with. So let's take a quick look through the stack. What are we dealing with? Well, of course, there's the hosts, be they Linux or Windows, the actual processors. Maybe they're in the cloud, maybe they're not. Very often we see containers. Microservice does not equal container, but container is an awfully convenient way to get piece parts into service, right? Deployed and operating. It's really cool new technology. It's much lighter weight and quicker. Tons of middleware. I firmly believe minimum 50% and sometimes even like 98% of net code running in applications these days are the middleware components. MySQL, Tomcat, JVM, the PHP server, the Nginx, the the Cassandra, all the big data stuff. That's all middleware, standardized components, but there's so much of it. Then the cluster's built up, right, to basically build a resilience and a scale strategy, and then finally, your code comes into play and creates those services. All right, now here's I think one of the main problems with the world of existing monitoring tools. They see a problem with any unit, with any component, as an alert. They don't have an automated way to structure that up into an understanding of true quality of service, and you end up with, when you're trying to monitor a new microservice environment with a traditional tool, a slew of alarms and alerts. And no, it's very hard to determine the real understanding of, okay, is this really an issue with the quality of service, or am I just experiencing effectively a planned for failure? Remember, we constructed these things with resilience, knowing that any piece part can fail. So an issue with a component probably does not, it may, but it probably does not affect the quality of the microservice, the ability of that service to deliver, its objective. So what are the new problems? The challenge of monitoring these microservices are as follows. First of all, deep, diverse technology stacks, and those are kind of two dimensions of problems. Within a given microservice, lots of layers, right? Lots of layers of structure that kind of all need to be working relatively well, even with the resilience to deliver the service. But then across, your environment, remember I talked about the polyglot nature of these environments that we find. Tons of diversity and lots of different big data structures, traditional data structures, tons of different middleware componentry that all need to be working relatively well. Second bullet, complex and unpredictable service interactions, meaning to accomplish the business process, it's a very chaotic set of messages that are kind of hard to figure out, especially by the ops teams and even for that matter for the developers. Third bullet, constantly changing everything. I mean, we've all, I mean, universally, we never find companies anymore that aren't agile development shops, which effectively means that, something's always changing, whether it be, just the simple code, or hey, they got to completely rebuild clusters, or now they're adding whole new services which are going to create whole new message flows, etc. It's just a churn. And then finally, scale, because even in small systems, there's hundreds of parts, and I feel like humans, a human runs out of the ability to kind of understand how it all fits together somewhere about 50. Somewhere between 50 and 100, the mind just can't handle that much, complexity or interrelationship between all these pieces. So it's time to have, a monitoring tool that can help sort all that stuff out. Now, let's step back and remember there is a simple goal statement when it comes to, I guess I would say deploying and operating a monitoring system. This has been the same goal statement for 20 years, honestly. We want to understand, we being the DevOps team now, quality of the system running, quality of the micro or macro services. I need that's what our job is, to deliver high quality so the business can operate. It's got to be in production. That's where the money is, right? And it's got to have minimal impact. In other words, hey, if I'm putting in my monitoring system and it's sucking down 10% of my, my capacity, that's probably not going to work. How about less than 1%? Way less. And finally, the last bullet is I don't want to be in the business of operating this tool. I want the tool just to help me. Zero configuration. That's always been the goal of these tools, and that really is not changing. We are just taking that to a new level. So now let's get to the product. Monitoring, what is it like monitoring with Instana? A modern application, as we just discussed, is the usage patterns, the message usage patterns across those microservices. So therefore, monitoring those microservices is kind of a requirement, right? To manage the application, to assure good service delivery of the business application, those microservices have to be operating properly, have to be operating with high health, with good health. Okay? So here's what we do. We manage by incident. We call it management by incident. An incident is essentially a small report, a mini report that correlates all changes and issues, any suspicious activity under the structure of that given microservice. Right? So the microservice, as you recall, right, is a buildup of middleware and hosts, etc. And now finally you've got the code that's creating that effectively API at the top. Right? So anything in that chain, that technical stack, that we notice as suspicious, we're going to build into this report. Right? When we see that there's a quality of service issue. All right? And here is how we determine quality of service. We raise an incident when quality is impacted, and quality is defined by KPIs. So KPIs that we monitor, that we calculate and monitor for each discovered microservice is throughput, latency, error rate, and saturation. Saturation is essentially kind of like backlog. It's kind of backup. It's like how much pressure how many built-up requests are not being serviced yet for that API. And then the health, KPI health, is determined by machine learning. And that is quite important also because of the ever-changing aspect of these environments and also the complexity of these environments. All right? So now remember, the microservice is a structured stack. And certainly, and also in the incident report are any suspicious, health issues in that full stack. So the way we monitor that, we monitor the health of each of the components. with what we call a curated expert knowledge approach. So let me just give a simple example. You know, the health of a MySQL database is a very different concept than the health of a Java machine, is a very different concept than the health of a Cassandra node, the health of a Redis cache, et cetera, et cetera. So all of these different, you know, middleware components that we're so dependent on these days, you know, they have a notion of, hey, what's good, what's not so good, and what's terrible. And we've built that into essentially an expert knowledge base and are continuously and automatically applying that to all the components to determine their health. And then that indicator rolls up into the incident. Now, how do we understand how a microservice is constructed? So this is, I think, one of the key innovations of Instana. It's actually the way that we internally model how all the piece parts fit together. And you actually don't ever interact with this. It's hidden. But essentially on the inside of our system, we have what we call the dynamic graph, which is a model to correlate all relationships and interaction between all those parts. So essentially, this dynamic graph understands exactly the architectural structure, the building block setup, if we will, that creates, including the, you know, the laying of the code into the system that creates the services. And then also how the business processes, shall we say, you know, are calling all of these different services. Now, if I told you, hey, the good news is I've got a graph that allows me to, you know, comprehensively model your architecture, but the bad news is you got to populate it, forget about it, right? Because remember, the dynamic nature of these environments, it's constantly changing. In fact, the shape of this graph, by definition, is constantly changing. And here's the great piece of news. We automatically populate it, and I think this is the second and maybe even the first most important piece of innovation that we've done. We've really rebuilt the idea of what an agent is. Now, you know, everybody is familiar. All monitoring tools have agents, right? You know, there's a way, they have to have a way to collect data. So one agent per host, you know, kind of per operating system. The agent can actually see through into containers, and its primary job is actually discovery. What are the piece parts running on this host? And building effectively a dependency understanding of, you know, how those piece parts interrelate. So in this example, hey, this Elasticsearch node is running, you know, alongside this Tomcat server on top of this JVM inside this Linux, you know, on this Linux operating system. There's no containers in this example, but they would be in there too. And that is all discovered and reported back to our, you know, to our knowledge base on the back, our knowledge engine on the back, and built into the dynamic graph. Now, also, when we see application sense, you know, servers like Java, Node, PHP, Scala, and you know, more languages to come, that's when we also can build or discover traces between the microservices, traces being messages to and fro, you know, between the services, and also build that into the graph. This will all become a lot clearer when we demo. Now, one last statement, and this is, I think, really quite powerful. We collect data in 1 second resolution. This is very important for a couple reasons. One is, again, the dynamic nature of these environments. I just need more fidelity, more accuracy as I look at, you know, how these components are behaving. There's another reason. We're applying machine learning to all of this stuff, and we need, you know, really precise data, you know, to calculate against, so that we can get a really tight understanding of what's going on, and then report that back to you in terms of the incidents and the, you know, health understanding of everything. Okay. It's time to switch to the demo. Let me say a few words about that. What we have is an environment of, you know, a demo application. We call it the online shop. It's got simulated traffic coming across it. It's made out of 22 services, written in Java, PHP, and Node, and then it's built on a whole bunch of middleware. Docker, you know, a lot of it's Dockerized, not all of it. Marathon, Spring Boot, Cassandra, Elasticsearch, Rabbit, Nginx, HA Proxy, et cetera, et cetera. Right? So we tried to do a decent job of kind of simulating a real, a real environment. It's got load running across it, as I mentioned. And then what we're going to talk through, what Michael's going to talk through, is a day in the life, of a DevOps guy using Instana. Ops is notified that there's an incident. He or she, come on, will identify and understand what that issue is, and then work, to remediate, etc. So, with that, let's go ahead and ask that second question, and then also switch over to Michael.
Yeah, let's take a look at the polling question number 2. So, guys, get your fingers ready to click yes or no. The question is, are you currently using your logging tools to enable monitoring? So it's a very simple one, yes or no. So we'll give you guys a couple seconds to log your answer here, and then we'll go ahead and take a quick look at the results before we turn it over to Michael for the demo, which I'm really interested in taking a look at myself. So hopefully we'll get everybody's votes in here in the next 5 seconds or so before we close things out. All right, polling closed, and it looks like 59% of you said yes, you are currently using your logging tools to enable monitoring. 41% said no. So interesting results, but I don't want to belabor the subject. So I'll go ahead and just turn it back over to Michael now.
Yeah, thank you very much. Can I share my screen? It will be perfect if you can hand over.
Oh yeah, we need to switch to Michael, please.
Oh, and as we're switching, so I think the question's open. So we take questions there, and please feel free to anytime post questions there, and I will jump on them as I can. So I said very briefly in the introduction, I'm running product, and I just want to walk you through what Pete said as a day in ops. I think you see my screen, the email?
Yeah. Yep.
Yes.
Okay, perfect. So Instana obviously has a lot of integrations as monitoring should have. And we have integrations into PagerDuty, and so on. But one very simple integration is the email integration. And this link actually, it sends me an alert, says, okay, there's an incident going on. And if I click on that incident link, I'm taken to Instana. And now you have Instana. It's fully web-based, so everything we do applies to web. And that also means that everything I show you now, you can simply share with your colleagues. What this specific link took me to is a view into an incident that I actually should care about, because incidents we always fire the moment a discovered service has an impact into a bad direction. And this is a red incident. That means it's pretty bad. And Pete already mentioned this. Understanding the service health is something we learn, and we automatically discover those services too. And I'll walk you through what that actually means. So on the left, we have a couple of incidents that during the time range were detected in the shop. And on the right, you get a detailed overview of the incident. What you get at the top is a couple of summarizing information, like when did it start, how long did it take, and how many events during that time period I'm looking at are active at the moment. You also have an overview of the time of the incident itself to get a better feeling of what actually triggered the problem, and at the end, how the incident evolved. But before we get into too much details there, let's look at the events. So this incident actually started out with a memory usage critical alert on the Docker. Please remember, we monitor, as Pete said, each component in your whole stack. And I will show you during the demo how that actually plays out. But what then happens is that actually Elasticsearch, an Elasticsearch node reported the status code of red. Then the cluster turned red. And this had a very, very big impact, because the Elasticsearch cluster itself, and if I click on it, this alert, had a sudden drop in number of requests. That means calls to Elasticsearch didn't happen actually anymore, because basically, and that's now the assumption if I'm an ops guy, something is wrong on the calling end. But the Elasticsearch cluster status red is before the case. So let's have a look. you see here the metric that actually fired, and you see that usually there were a couple of calls a second, and then it dropped down to 0. I simply, with shift and dragging the mouse, can now mark that time area that interests me and can investigate the incident in more detail. Please do remember, you just deploy the agent. Everything you see here falls out of the box right into the interface, and you don't actually need to configure anything to get this view. So I now understand there's a service that where the calls dropped out onto a critical level, and again, this is understood by machine learning. If I now drill faster down and I want to understand what actually is the big impact I have, is that my shop itself, and this is now the crucial part for ops, so I'm running Elasticsearch and maybe something failed sometimes, but the really big pain comes the moment the shop itself is impacted. And you see here there's a service impact telling that there's a sudden increase in the number of errors on shop. So this is crucial. That means, translated to the shop application itself, that means that my shop actually, during the time the Elasticsearch cluster failed, went to an error rate of 100%. So I marked this area before, and now I immediately see the correlation of this impact of the Elasticsearch failure. So this means the failure actually led to the shop being down technically, because 100% error rates means no one can buy. They potentially can't even search. So quite severe impact. But we told you we do more than this. So we now understood the impact. The incident has been created. It already told where to look at and where the problem started. In fact, up front was oversaturated or under-provisioned Docker, and it spread out a bit. But the next step that actually happens is that we also detect and track all the changes that are during the incident happening in the infrastructure components. And a couple of things in Elasticsearch, especially on a red status, is that actually shards are not allocated properly. And you now can see easily, because someone triggered relocating in fact, and someone sized out and brought up a new node, which is actually shown here, that a Java component comes online, which is in fact an Elasticsearch node, that by doing that restart and by fixing it, over time, the issue actually resolves itself until it is finally done and the problem has been resolved. So you don't only have the root cause, and you don't only have the information and what's actually happening during the remediation of the problem, and upfront you're alerted, but you also understand what's needed and what's successful to resolve it. But this is one part. So I now have this very, very fast overview. I usually can now dispatch it to the correct people. If I can't solve it, simply share the link and go into it. But I also am able to see what actually does that mean in my microservice environment. So I now switch to the application map. And you now see the application map during the time of the incident itself. During the time of the incident itself means, and please have a look down at the interface, during the time at itself means that the time picker, which is the bluish piece here, this environment looked exactly this way. There's my shop service, there's my product search service, and there's my product index of Elasticsearch. If I now would move the time picker around, actually what we would see is that a couple of minutes before that, this problem didn't exist. So again, let me move forward, and you see the change. This change of the time picker is always going through the graph and always detects all differences in the environment. That means if your landscape changes, if that is discovered, this actually is reflected. So having said this,
let me,
by the way,
Michael, let me just make a quick comment there. If you recall back to that dynamic graph diagram that I showed, that graph is essentially persistent. So the internal data model is a persistent thing. You can kind of think of Instana in a way like a running DVR of your whole environment, and that's what Michael showed you by going back and forth in time with that, that vertical blue line on the bottom there, then always, of course, can go back to live any moment. Keep going, Michael. Thank you.
So let's understand a bit better what actually is shown here on this map. So all those circles here are discovered services. We discover those services by tracing the application end-to-end automatically in the presented languages, and very soon more languages. And this discovery of the services is also done fully automatic. I even can turn on the particles, which show the real-time flow, and each point moving here is one call of the whole application landscape to get a very fast understanding where a lot of load is happening, and especially here where errors occur and where traffic is simply not present anymore. So you see this, there are red dots moving. If I move back in time, you will see that the picture changes, and during that moment the calls to the product index still worked. So going into the problem again, you again can investigate this. So this helps our customers to understand problematic situations and to deep dive. But before we do the deep dive, let's go a bit more and understand the impact better. I can select the shop service in this example, again automatically discovered, and the shop service here itself is underneath powered by a Spring Boot application, but I'll come back to that a bit more later. So I now have the sidebar of the information of the shop application, and as I open the dashboard, you will easily see that the error rate is too high and that I have a sudden increase in number of errors. Those are our machine learning-based health rules kicking in. And you also get the information of how that actually looks like. And just to be very clear here, those metrics, and I turn to live in a couple of minutes, they stream in on second level, and we have second granularity here. But let's go back to our problem. I see calls dropping during this period of time. I have a distribution information based on percentiles of how my call runtime actually is distributed, and I have the error rate popping up here, and the instance count. And I have all the information on the inbound connections and on the outbound connection to understand where the actual issue lies. And I easily can see it's just an issue with my call to a product search. So I want to just focus your attention on this piece. Unknown to shop is actually your customers. So your customers during that time experienced an error rate of 100%, which is damage. So now I know this, but what's the next step? I might need to hand this over to development. I might need to hand this over to someone who actually needs to look into maybe something in the code is broken, maybe something can be improved. What we have as a solution for this is the trace view. On the left, you see the number of traces for that shop application during the selected moment in time. And with a click on it, I'm taken to our trace view. Let me sort by error count because we want to focus on the errors. And now I have each trace, and let me repeat this. Each trace for the application in that moment of time of the incident we faced. A trace, as Pete said during the presentation, is tracing a distributed call throughout no matter how many services, asynchronously, using queues, using different languages. Instana traces all of them. Our overhead is barely measurable, and there has been no customer at all so far that had any problem to measure, well, to at all get our overhead. So everything is running fine here. And you now have one call of the environment, and you can easily investigate this. You can see the get shop call on the entry service, returned a 500 call. That itself made a call to product search and handed it over. You even have the network timing for that call, for the handover to the different service, and then you see the log output that actually was thrown when calling the Elasticsearch. If you then want to even go deeper and understand which specific line of code in production does the call, you can always go to the stack traces, click on the show code, and what we do is we actually fetch the class underneath, decompile it in the backend, and we take you to the exact line of code so that you can easily understand which part of code did this call, investigate it, and maybe improve it, or just hand it over directly to the persons who can and should have a look. So the traces themselves are the means to further look into each execution to understand what happens, distribute it from each call, also look into for example, SQL statements or other statements that are piece of the payload to other systems, and investigate them further. If you now would say, okay, that's kind of okayish, but I still need to look deeper. This is now the piece where the infrastructure plays in, because microservice or Azure environments doesn't necessarily, or at all, they don't mean that you don't run infrastructure, either you're on cloud or on your own premises or whatever. Underneath, it's still the components. So let me look a bit more into the Spring Boot application. And with a click on the Spring Boot application, I'm taken to the infrastructure component actually implementing that specific service. And in this example, it's a Spring Boot application. And by the way, this all is automatically discovered. I will show that to you in about 2 to 3 minutes. And you see our Spring Boot sensor, which actually shows the rise of the status code 500. But I want to take you a bit down to the JVM, because the Spring Boot application implementing the service, in fact, is a JVM, is an OS process running in a Docker container on a specific host. If I now go down to the JVM dashboard, I get all the metrics for the JVM and actually have all the information to understand the JVM better, with the capability to actually get a thread dump to get more information on the JVM's threads. So troubleshooting-wise, I have the problem. The incident told me where to look. The incident actually helped me to understand where the problem raised from, how it has been solved, what to do. We have all the recommendations. We can go into a trace each and every single call, go down to the code level, and then look into the problem deeply.
Yeah, let me jump in there and just say, and that's all of this, ability to kind of jump back and forth between the different technologies, and exactly go from the trace to the Spring Boot that was running that trace to the Java machine running that Spring Boot, etc. That's the power of the dynamic graph, right? That's the power of having a comprehensive architectural understanding, underneath the monitoring solution, and no other solution in the world has that. Data models on monitoring has always been more focused on just cataloging the metrics, but not enabling an understanding of correlation, between the components. So that we really feel strongly that this empowers the people doing the troubleshooting. Thank you. Go ahead, Michael.
Thanks. And now let's see how all this is made. So I will now go into the infrastructure map. This is the infrastructure map. It is focused on the infrastructure level, or a visualization of the graph infrastructure focus. In fact, OS focus. Let me switch to the live mode, because now we are in the moment of time, which is now. Let me zoom in a bit on the timeline. And now this is the actual state of the environment. It is in different zones. There's a bit of scaling going on. So if I move back and forth in time, you will see the map changing, and you will see that, for example, the scaling disappears completely. And again, this is updated immediately and reflects the changes. But I want to focus on one specific box, because I wanted to show you how we actually work. This box at the moment doesn't run a lot. Basically, it just runs the OS. I open it up, I open the dashboard, and you now get all the information on the host itself, on the OS instance. If I zoom into a minute, you will see the metrics streaming in actually. And let me pop up my terminal. So I'm logged into this box, and at the moment there's nothing running. If I now would like to spin up a couple of Docker containers, which actually this shell script does, you will immediately see that on the top left the usage spikes, and you will immediately see also that the graph reflects this. So immediate feedback, it's obviously nice to have, but the value of it is, as soon as you change something, as soon as you interact with your systems, and as soon as you get, or as you need to have feedback, the system will give it to you. And the only thing you need to do basically is to install the agent and fire it up. That's it. The agent comes containerized. We support, therefore, various systems, and it's easy to deploy it. We also have all the scripts to run it with Puppet Chef and so on. And what now happens is that the system fires up a couple of Docker containers, and we already discovered them. So the first Docker container seems to be running on the left, you see it, that we now already discovered the Docker containers, including Zookeeper, managing actually in this example Kafka, and applied all the sensors and the discovery for it. And this discovery is ongoing. So as soon as something changes, or as soon as something has a problem, or something pops up, or you spin it down, you can easily and automatically will have this discovered. And this is the timeline. If you expand this, you will see all the changes and the online events for all the containers I just started. And let me go just to show you that into Redis node we just spun up. So I go into Redis, and you now see our specific sensor for Redis. So each sensor we build is fully tailor-made for the technology to monitor. It has specific knowledge to actually reflect if something is problematic and you should care about it. And in this example on the Redis, you have a couple of information on it. Again, we have this for all technologies. And I want to just point you to it. This Redis is in a Docker, and also the Docker is discovered and is also monitored therefore. So if you have an issue with Docker, you will easily see it, and Instana will point you to it, and this will speed up your time to understand the situation. But just to show you one thing more, and this is the piece of the discovery, this doesn't stop at a single component, but as Pete said, it's also important to understand clusters. So what I now do is I select an Elasticsearch node in our demo system and open up the Elasticsearch dashboard for it. This is just one node with all the information, if it's master legible, if it is master, and all the information you should have on an Elasticsearch node. But also, we discover the clusters actually delivering the service, here in this example for Elasticsearch, with the information of overall cluster steps, as well as the information on the node itself. And if something breaks here, for example, the Elasticsearch turns red, then we inform and actually learn the impact and prevent that to you. And with all our technologies, and coming back to our application, also for all the technologies where tracing works, so the languages it's written in, we will automatically trace the application, and your service will pop up here automatically connected with all the information, and you might just deploy another shop node to solve the problem we faced earlier with maybe a new version that is fixing it, and you will see its performance in real time. And as soon as the problem arises, we will tell that in an incident, including the root causes and the steps that you might want to take.
Yeah, that's great, Michael. So let's, I think there's been a couple of questions that have come in, so why don't we take those?
Yeah, sure. We do have one question that Roman sent in asking if does Instana work with platforms as a service like Pivotal Cloud Foundry?
Yes. It basically does. Yes.
That's an easy answer there.
Yeah, let me make a sort of additional comment to that. Yes,
Sure.
Instana is available as a SaaS solution. You know, we're hosting it. But also we do have a on-prem version where the customer can build their own Instana service inside of their data center. So go ahead.
Great, great. Actually, we just had another one come in. Christian asked, is there a community version available? And then you have a big smiley face there.
No, we do not have a community version. This is not an open source project, although we are going to, in the future, kind of do a strategy that lets people add their own sensors and kind of build out the community of things under management, if you will. So we're going down the path of the other APM tools, which is software for hire. Put it that way.
Great, great. Well, I'm sure Christian enjoys that answer. Great. So just a reminder to the audience, if you do have a question, please feel free to get it in now. As you can tell, we are asking the questions as we go along here. We just had another question come in from Hytham, and I apologize if I mispronounced your name. What is the pricing model? Is it per agent, per CPU, or something different?
Yeah, good question. We actually have two models. And Michael, could you do me a favor, pop onto the infrastructure screen and maybe zoom in on, a particular server that's got a lot of piece parts. So one model is per host per year. No, sorry. Stay on the like zoom in so I can see like a server with a lot of containers in it as an example. So one model is per host per year. That is $350 per year per host. That's the base price for that. But we also have a model in highly dynamic environments. We get the question a lot, hey, I spin things up and down all the time and I don't want to pay for monitoring when I'm not using it. We also have invented something we call the SIM model, software instance minute or sensor instance minute. And the idea there is, every component you currently see on the screen, the host, and then every one of those sub-internal boxes is a unit under management, essentially. We're collecting data from that thing and we're, monitoring its health. And we have a pricing model that is per component per minute. And in that world, it's kind of like the filling your car up with gas. You buy a chunk of SIMs and then you burn them off over time. You got a year to burn them. And then we have a portal which helps you understand, your SIM consumption, et cetera. So we have these two models, and, it's kind of easier to think about and get started with the per host model. But then if you have highly dynamic environments or a lot of containers, because on our host model, we do have a max of 10 components per host, a maximum. So there it is.
Okay, great. Doing a quick time check, we have about time for one or two more questions. So if you do have a question for Pete or for Michael, please feel free to send it on in. I do have another one here. How does Instana discover the existence of a microservice? How does that work?
Yeah, good question. Go ahead, Michael. Take that.
I would say define microservice versus normal service. So basically, we discover services, and if it is a microservice, and again, however you want to define that, it's basically the same discovery mechanism. However, we go great lengths to support the containerized environments, which we see a lot in microservice environments, and to also be able to discover ephemeral resources which are not running like hours or days, but instead a couple of minutes or less. I don't know if that answers the question, but in short, we don't need to separate. We simply discover both.
And I would answer it by saying, maybe another way to ask the question is how do we discover an API's existence? The fact that service calls are going in and out of a thing. Well, go ahead and answer that question, Michael.
Okay, brilliant. Thanks. So basically, those services are discovered by understanding the application calls during tracing. And those services themselves, we have rules to understand the services. They are different web API, MySQL, or databases, and so on. And that's the way we discover them. So we analyze all the traces, they're distributed, and understand the APIs or the common APIs, and by that group the services. However, if you want to change the grouping, configure that, you're free to do so.
Yeah, nice.
Okay, great. So please note that if you haven't gotten your question answered during the webcast, I'm sure they'll be more than happy to, Pete and Michael will be more than happy to take your questions offline. But I think we have time for one more question here. The question is, if a container comes to life with identical code inside of it to an existing container, is this discovered as a new service?
It depends what it runs. to be honest. So if it runs the same code and therefore exposes the same services, it would be discovered as another service instance. So for example, here on products, we have 2 service instances. And in fact, we would understand it's a different container running a different component, but it exposes the same service. So we would say it's another instance of the service, but running on different components.
Okay, great. All right. Yeah. Well, then I guess at this point I'm going to go ahead and turn it back over to Pete, and you guys can kind of close things out.
Yeah. Pop, if you don't mind, pop the screen back to me, and then I'll just summarize with a couple more slides. There we go. Thank you. So just to just to summarize, I mean, again, let me remind everybody that this world of application performance management, the APM tool space is a fairly large space. It's running at about $3.5 to $4 billion a year. That's coming from Gartner research. And there's a reason for this, right? I mentioned early on, just the when companies make big investments into their applications, it pays to have the right tooling to really assure that the operations team, the whole IT organization, shall we say, can do a good job operating that thing. But a lot of times people also want to understand, okay, like I have 3 core constituencies in my DevOps organization. There's the developers, there's the operations team, specifically, and then there's also product owners. So we just wanted to summarize and end this by saying, okay, let's look at the value that we really deliver to these various constituents. So as you can see during this demo, right, to the developers, we give a really precise understanding of how their code is running in situ, I like to say, runtime behavior and architecture in production in the real world. So they can come into the tool and really explore how their code is behaving in that real world. Identify bottlenecks, spots where code can be improved. When there's an issue, troubleshoot precisely what the performance bottlenecks are and where the errors are really coming from. And then another interesting value is, okay, hey, we know that at 3 p.m. we're pushing new code, right? It's going into production at 3 p.m. It's going live at 3 p.m. Let's look at the before and after, right? Let's use that time shift and look at, the response time of my service at 2:59 and look at the response time and error rate at 3:02. All right, so really do a nice comparison between those 2 worlds. To operations, full stack visibility and navigation, right? No one hands those poor ops guys a map of how this whole thing is structured up. That's what we've got, an automatically discovered, continuously updating map of the universe that allows, anyone, but operations in particular, to go back and forth between all these layers, right? Go from how is the code working, how are the services operating, let's go look and see how the infrastructure that supports that is operating right now. Let's look at the health of all these different components and understand that structure from infrastructure to application to trace and back again. Secondly, automatic and intelligent incident management, right? No configuration approach to understanding quality of service, and then that same ability to drill back and forth between the layers effectively in real time. We didn't talk about this much, but the time delay between new situation in production and us recognizing that is only 3 seconds. You saw it when Michael gave that demo when he started up those containers, right? You saw how the CPU, he hit the return key, and about 3 seconds later, you saw the CPU button or the CPU meter go up, in real time. That's across the board, right? Incident management, incident calculation is essentially constant in about a 3-second delay. That's quite interesting. No other tool has that. Usually, monitoring tools take 3 to 5 minutes to figure out what's going on. So we're 3 seconds. And then finally, the product owner, the person responsible for driving the DevOps team, or driving the dev team forward with, and owning the functionality of the service / microservice. Understand the utilization. Hey, who are my consumers? How are they using it? What are the dynamics of the various users? Manage the performance, of the service, but also understand, the various, differences when I get different usage patterns, identify improvements, and then finally prioritize and help understand prioritization based on impact. So I think we're done. I do encourage you. I want to one shout out. We will be at the Amazon reInvent show in 2 weeks in Las Vegas. Come find us. Come on by, say hi. We'd love to meet you. All right?
Great. Thank you, Pete. And thank you, Michael. Thanks to you both for taking the time and being a part of this webinar today. I got a ton of information from it, and I'm sure our audience did as well. Please be sure to check devops.com for future webinars. And then also, as I said earlier, this webinar was recorded, so check back in about 24 hours if you'd like to watch it again. But for now, I'm Charlene O'Hanlon, and I'm signing off. Thank you, everybody, for joining us.
Yeah, thank you all.
Thank you. Bye.
Bye-bye.